Alright, so you should have just completed your quick quiz. I'm going to ask that you guys go back to your desk so you can do a homework check. Once you're done your homework check, go ahead and discuss homework questions. If you don't have any questions, you can go ahead and get started on the warm-up. There is a typo on the warm-up. If you guys could please change the first question to have the t in the numerator, not the denominator. And then Ms. Stedman, give them some time to work on the warm-up. Once they seem like they're ready, let's go over the warm-up, and then we'll go back and see if they have any leftover questions from homework. I will need at least 20 minutes at the end to go over the lesson, though. So go ahead and press pause. Alright, so at this time, you should have had some time to do your warm-up. Hopefully in your groups you've been able to get through it. So this guy, we're going to do our u to be t squared minus 1. How do I know this is a substitution problem? Number one, there's a quotient, there's a chain. I know I can't simplify this, and then also on top of that, I know that the derivative of u is 2t, and this t is the issue up here, and that's multiplied by my dt, or it should be, because I did not rewrite my problem. Sorry about that, guys. There we go. Alright, so I get du over 2t is equal to dt, and just to save a little bit of space, I'll be able to cancel that t with this t. I know that the left side, the integral would be v. The right side, I would end up with the 3. I'm going to pull in front of the integral this half right here. I'm going to write underneath the 3. And then integral of 1 over square root of u times du. Remember, we replaced the dt with a du divided by 2t, but the t's canceled and the 2 is still sitting out front. Alright, so v is equal to, let's actually rewrite this too. So 3 halves, integral of u to the negative 1/2 du. So that add 1 would be positive 1/2, so therefore in front here I would end up multiplying by 2, because dividing by 1/2 is multiplying by 2. So I get this as my answer, so I get v is equal to 3u, which was t squared minus 1, to the 1/2 plus c. So that's the first question of the warm-up. Hopefully you had enough time to do the second one. If not, Ms. Stedman, if you have enough time, you can press pause and give them a little bit more work time. Alright, second one. Solve the differential equation with the initial condition of y of 0 equals 1. Alright, dy, I would have to divide by y. I would have to multiply by dx. Remember, if there's just a dx, it's the same thing as you thinking about that being just a 1. Alright, left side, that's easy. Ln of absolute value of y is equal to x plus c. Remember, the derivative of x would just give us that 1. So, if I want to eliminate the ln, I'm going to need this guy. And remember, I'm going to skip a step right here. I'm going to write it as e to the x times e to the c. To eliminate the absolute value, I would need a plus or minus, and then I'm going to move the e to the c in front, e to the x in the back. And then I'm just going to replace this piece, the constant, with an a, e to the x. And then I'm going to use my initial condition. This is my x, this is my y. So my y is 1 is equal to a e to the 0. E to the 0 is 1, so therefore a is equal to 1. And my final answer to the warm-up is y is equal to 1, e to the x. So it's just e to the x, oddly enough. Alright? Y of e then would be e to the e, letter A. Ms. Stedman, if I made any mistakes, go ahead and please correct them. Alright, slope fields. Here is where we're going to get going. So, Ms. Stedman, if you want to pause for a second to take any homework questions, again, I'll need about 20 minutes, maybe actually 25, minutes to get through the notes. Alright, so looking at the slope fields here, we are going to start off by trying to understand what a slope field actually is. It is going to look like a bunch of tiny little lines all over your paper, but those lines are really specific. They're actually going to be mini tangent lines. So, what do I mean by that? This just says that the slope of the tangent lines are 2. So every single tangent line, no matter where I create this tangent line, will be 2. Now, a little thing to understand from before was, remember when we tried to solve a differential equation and I don't give you an initial value? Remember you always end up with that plus c? That plus c pretty much tells us there's an infinite number of equations that would match that differential equation. Meaning, for this guy, I could do 2x plus 1 could be a solution. 2x plus 5 could be a solution. 2x minus pi could be a solution. So there's an infinite number of solutions, and that's what a slope field does. It references the fact that there's an infinite number of solutions. So the way we make a slope field, and we're only going to do a few, I'm not going to create an entire slope field, it takes forever. You're going to pick a point, let's do 0, 0, and you're going to create a tangent line whose slope is 2. So what you're doing is, in your mind, you're creating the whole entire line. So I'll do it, this would be about a slope of 2, right? But you're not going to draw all of it. You're only going to draw a tiny, tiny, tiny piece of the tangent line. And then you're just going to keep going. And you're going to create tangent lines of 2 across all the points. You pretty much just need them to slope about the same. They should all look parallel because they all have a slope of 2. So let's do maybe this many of them. We'll do some that are negative. Alright, so that would be a slope field. That slope field pretty much would tell us that anywhere I go in the slope field, the tangent line is about 2. Now, the slope field has more of them. We could even put them in between where there isn't an intersection of integers. We could do things like this. But then it just becomes so burdensome to do. So your AP test and I myself will only ask you to draw slope fields on integer values. Okay? So this one now is a little bit more difficult. Now it says that the slope is x. So if I pick a point, 0, 0, the slope is going to be the x value at that point, which would be 0. So if I pick the slope of 0, 1, the slope is 0. Point at 0, 2, slope is 0. So you'll notice all of these would have a 0 slope. Then when x is equal to 1, 1 comma 1, that would be a slope of 1. 1 comma 2 would be a slope of 1, slope of 1, and so on, right? And then when I go to a slope of 2, I'm just going to change my color. I would do a slope of 2, which is slightly steeper. And then a slope of 3 would be much steeper here. And then the left side, this would be an x value of -1, so these would have a slope of -1. And then these would have a slope of -2, which is steeper. And then these would have a slope of -3. And then if you really look at this and you kind of squint your eyes a little bit, you can see that it starts to look like a parabola, because we know that the answer to this differential equation is x squared plus c. You should see that it's a bunch of parabolas that are shifting up and down. That's pretty much how it works. Underneath here, you'll see these questions show up a lot. When is the derivative greater than 0? So when is the slope positive? Always. When is the slope negative? Never. It's never 0, and it's never undefined. And that should be easy, because the slope was 2. In this case, these slopes now change because the slope has a variable in it. So this one, the variable was just x. So when would my derivative or my slopes be positive? That was whenever x was positive. This was whenever x was negative. This was when x was 0. And this is never, because x is always defined. And then the third one, instead of creating the slope field, I actually want to focus on answering the question down here. When would the slopes be positive? Well, whatever x value I substitute in here, you should realize that it's always going to be positive. Therefore, all real numbers never, except when x is 0. So when x is 0, it makes the slope 0, and it's never undefined. That's actually really important to be able to understand. It's very similar to doing domain and range. So now I could potentially have slopes of just y, and we've done this before. We've done separating differential equations, so we've seen that before. So if you want to create the slope field, you're now using your y's. So here the point 0, 0, the y value is 0. Here the point 1, comma 0, the y value is 0. So you can see where all your 0 slopes would be, which are really important to know. And then pick more points. So 0, comma 1, well the slope would be 1 here. 1, comma 1, the slope would be 1. 2, comma 1, the slope would be 1, and so on. So here all the slopes are 1. And then 0, comma negative 1, the slope would be negative 1. And these would all have a y value of negative 1, therefore they all would be negative 1. These would be points at negative 3, comma 2, the y value is 2, so the slope is 2. And all these y values being 2 makes all the slopes 2, and makes all these slopes negative 2. Okay? So, let's go through answering number 5. When is the slope positive? Well, the slope is positive whenever the y is positive. When is the slope negative? When y is negative. When is it 0? When y is 0, and it's never undefined because we can always find a value when you substitute in for y. This guy over here, same thing. I'm not going to create the slope field, but I want to answer the question. When is the slope going to be positive? Well, let's start with the 0. It's always easier to answer the 0 question. This would be 0 when y is equal to 0. Therefore, it's positive because it's a y squared when y is greater than, oh sorry, not y is greater than, for all real numbers except y cannot equal 0. Because if it was 0, the slope would be 0. This is never, and this is never, just like before. Okay? The more complicated one is when they start mixing your terms. They give you x's and they give you y's. And these are usually the ones where people know how to do them, but you make a calculation error. So I think that the best way to do these problems, and we're not going to do too many, let's just do this little piece. So what I tell students to do is create a table that match the points. So what do I mean by that? So the highest y value we're going to look at is positive 1. And then the next y value is 0, and then the next y value is negative 1, and then we'll do a left. So remember where the box was? We're going to do x values from negative 2 and over to 2. So that would be the table I would create, and then I would sit here and I would write in all the slopes. Okay? So x divided by, that negative note. So x divided by y squared would be negative 2. X divided by y squared would be negative 1, 0, 1, and 2. Next one, x divided by y squared, undefined, 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 undefined. And then x divided by y squared, so these would all become positives. So then we go negative 1. So they look pretty much the same as before. And then once you have that, then you would create the slope field. Wherever you have the undefined, you're not going to create a slope at any of those. So at the point negative 2, comma, positive 1, that would be the slope. You do a slope of negative 2. At the point negative 1, comma, positive 1, that would be this one. We do a slope of negative 1. And then a slope of 0, and then a slope of 1, then a slope of 2. And then go ahead and finish up all the points. There are many of them. There's 10 more to do. Actually 5 more to do because the undefineds help us out. So at negative 2, comma, negative 1, the slope is still negative 2. They're going to match the ones that were up there, so I'll do that pretty quickly. Most probably you'll do 12. It's usually about 12 points that the AP asked you to do for a slope field. So for this guy, it's a little bit harder. So this one, dy dx, is equal to x over y squared. So what you'll notice is y squared, pretty much, what did it do? Well, number one, it was the only time it caused an undefined was when y is equal to 0. We were able to get a 0 slope when x is equal to 0. But there's a restriction that y can't equal 0, because 0 over 0 would be undefined and not 0. And then now to get your positives and negatives, remember the y squared, it's always positive, so it doesn't change your sign whatsoever. So this fraction is positive when the x is positive, and this fraction is negative when the x is negative. Okay? So same thing here, we can do a smaller little grid, maybe just this much of it. So my setup would be the highest y value of 0, and I go down to -1, and my x's would go from -1 to 1. So that would be the grid I would create. I actually trust you guys to do the grid. So Ms. Stedman, if you want to give them a second just to fill out the slope field, if you could walk around and make sure they know what they're doing for the slope field, and then we'll talk about the bottom section. So Ms. Stedman, I'm hoping you were just able to kind of peek. Go ahead and raise your hand if you're still having a little bit of trouble making the slope field, and Ms. Stedman or one of your group members should be able to help you. I am going to get started at the table at the bottom. So in answering when this is going to be, and the easiest ones to answer are your undefineds and zeros. So let's start with the undefined. We know that that's never going to happen because there's no fraction with a variable in the denominator, there's no variable in an even root, and there's no variable within an ln or a log. Those are our 3 domain restrictions that we use. When can this be 0? Well, 2 different ways. We can solve this x squared equals 0, and then we can also solve y minus 2 is equal to 0. So x equal to 0, and y is equal to 2. Those are the 2 times that we would have a 0 slope. So how do we get positives and negatives? Well, one more time, this does not matter for positives and negatives because it's always positive. So y minus 2 is equal to 0. You guys probably don't need a sign chart for this, but I'm going to make one. If this is my y value of 2, at 2 it's 0. If I pick a y value that's over to the left, like 0, it would be negative, and y value to the right, like 100, would be positive. So I know that when y is greater than 2, I would have a slope that's positive, and when y is less than 2, I would have a slope that's negative. Okay, so take a look. These are very usual questions that you get asked on the AP when doing your slope fields. So I'm going to actually come back to this one last. It's just a matching question, which is also pretty common on the AP. I'm going to give you guys some time to work on this, which is kind of a nice little review of most of what we've just done in Chapter 6. So if you guys could please take some time. Ms. Stedman, if you could get them to work for maybe 10 minutes on this problem, and then I will start writing up the answer up here, but I believe they might even have the answer in their packet. So I'll start writing up here. If you could just let them work for a little while. If you need to pause it because they need more time, you can do that also. Alright, Miss Denman, if you need to press pause to give them more time, please do so. Otherwise, I'm going to just walk through the solution with them. And if class has ended or is ending, they can view the video online, obviously. Alright, so to start off, letter A, I just created my table of values up here, and all of those red values are my slopes. So I had to do x squared times y minus 1. I actually started off with wherever my zeros were going to be, and I put those in first. Therefore, I only had to find 6 slopes. And then my slope field was created. Letter B was pretty easy because you have that x squared, which does not affect the signs whatsoever. So the only thing that affects the signs is the y minus 1. Most of you can figure out without a sign chart that y minus 1, that would be where y is greater than 1. Letter C, a little bit difficult of a problem. So when we're looking at the problem, it had a quotient rule, or the other way to look at it is I could have rewritten the problem as y minus 1 to the negative 1 dy, and that would have been a chain rule, but either way, I have to use substitution. So my u was the denominator, y minus 1. Other thing, if you remember me saying, anytime your denominator is a linear function, then that's a ln problem. Okay, just a linear function down there, no power for the variable and no power of the whole entire thing. That was a nice substitution because du equals just dy because the derivative was 1. So the substitution just gave me du over u, which is right here. So right here is all the steps to solve for the y. So I used e on both sides. Remember, if you have e to the a plus b power, that's the same thing as e to the a times e to the b, and that's what I used in this step. And then I needed to eliminate the absolute value, so I have the plus or minus, which eliminates the absolute value, and then I rewrite this piece, the constant, as a constant a, and then we were able to solve for the whole entire function, which is here. And you do have to solve for the y. Now the last piece that I need to do, which I'll do right above, is to use my initial condition. So my y value is 3, and it told me that my x value is 0, so that would be e to the 0, which is 1, so a is equal to 2. Therefore, I'm going to rewrite my equation as 1 plus 2e to the 1/3 x cubed, and hopefully I didn't make any mistakes. That should be the free response question. I am going to go back and take a look at the differential equation, the matching one. This one I thought was a pretty tricky problem. It is really interesting because usually what you want to do is you want to look for easy things. You want to look for where the slope is 0. And I think I'm having a hard time because there's no scales on this. I'm going to be honest, I'm going to take this question away because there's no scales, and not having scales makes this problem even more difficult. Ms. Sedman, if you want to go over it with them, I'm assuming we're probably out of time anyway, but you're welcome to go over the problem with them if you can physically or visually really quickly see the solution. Well, maybe I'll do it. Maybe I will. No, I'm not. Sorry, guys. I'm going back and forth. Most of the times your slope fields on the AP always have units, and it does help a lot to have units. So I'll just do another example on another day. Okay, so that should be the video.